Hello friends, and today we'll be doing the data analysis of Boston dataset. So open your Jupyter notebook, launch it, and go to data analysis, the folder you have created for your various data. And for this, we go to new Python 3 and we create Boston dataset, Boston analysis. So what is this Boston? This is a housing price data and it is a regression problem. And we'll understand more once we start doing it. So what I do is import basic libraries. You start by importing basic libraries and hit here, press 2, shift enter. This is heading 2. Okay, spelling right. So what I do is I import pandas as pd. This is for CSV files for your data processing. Import numpy as np. This is for linear algebra. And I will import two plotting library, that is matplotlib.pyplot as plt, and I'll import cburn as sns. Hit shift and enter to run this code. Now what is, from where do I get this data set? I'll get it from sklearn. From sklearn.datasets I will import load Boston. Okay, this is how you write sklearn le. So that has been loaded. Now what I do is, in a Boston object I create, you can name it anything, I will load this Boston. I load this Boston on the Boston dataset. Now let's see how this Boston looks like. Okay, we've got data here, we've got target here, a huge array, a lot of numbers. Okay, we've got feature name here, we've got description here, and you can see the number of instances 506, number of attributes 13. They are numeric or categorical predictive. Okay, what else is there? Fine. So let's just derive each value here. Now if you want to see Boston dot, write on Boston dot keys, and what will happen is it will give me a dictionary of keys, and that's what we've explored: data, target, feature names, description, file name. Now if you want to see individually Boston.data, see Boston.data, it will give you the same thing, an array of so many numbers which we don't understand. And also let's see Boston.target, and it will give me again an array of so many numbers. Okay, now let's just explore further and we see Boston.feature names. What is this feature names? Let's see. This is something called this, and there are 13. Okay, then what we'll do is let's just print Boston dot describe and see how it looks. So this is a Boston house prices data set, and you've got number of instances 506, and you've got attribute 13, and we see that the data is not arranged, so we have to arrange these rows and into column format. That's what we are going to do next. Just understand what are the attributes mean. This is crime rate by town. This is residential land zone for lots over 25,000 square feet. Okay, this is the non-retail business acres per town. Chaz is the Charles River dummy variable, and it is being converted 1 if the river flows through it, and 0 if it doesn't. And this is NOx, this is nitric oxide concentration, how much polluted that region is. and this is rooms, average number of rooms per dwelling. What is the age of the owner who occupied, this building prior to 1940? Okay, then this is the distance to 5 Boston employment centers. Similarly, taxes there, parent teacher ratio, how many parent teacher ratio, matlab how, and black population, and further 2 more. So these attributes will determine the pricing of the data, pricing of my Boston houses. So how each attribute influences it, let's see. So I click here so that it goes. Then what I do is I convert the data into pandas data frame to make it more representable, right? What I do is in an object I just write pd dot data frame, and in that I want Boston dot data, and columns is equals to Boston dot feature names. Okay, and let's just see, this df dot head will give me the above 5 entries, and see, it has been arranged into a table format. So these are the columns and these are the rows. Now if you want to see the last entries, just write df dot tail, and by default it will give you the 5 values. Suppose if you want to check 10, so in this just write 10 and you get the last 10 entries. Okay, tail is last 10 entries. Check the shape of the data, df dot shape. Okay, it's just so it's 506 rows and 13 columns. Okay, so you see that target is not included here. Now what you do is you include the target here. So in the df I will name it as target, and in that I will include Boston.target, which we have. Okay, and now you just again check it, df.head, upper 5 values, and see the target has been included in it. So now we can proceed on to further exploration of the data. Let's check the shape of the data, df.shape, see 14. Okay, 506 rows and 14 columns. You can check the data types. Okay, so check the data types, and here you will just write df dot d types. Okay, df dot d types. So you see all data is in float. Okay, so we've got numbers here, no problem. Let's check whether it is having anything to do with null values. Dot null dot sum, and we see that there are no null values. See, no null values. What happens if there is null value? Suppose if there are like 2 or 3 here, so we have to replace that null value, because if we'll continue with that, we will likely to get an error and our algorithm will not accept this data. So we see that there's no null value, which is good. That means we don't have to fill these values. Okay, next we go to df.describe, and in this describe I will see, okay, let's do dot t. I have just transposed it, and you can use it without transpose. See, without transpose, that means transposes rows are converted into columns. So I've converted these columns into rows. So just see crime, the count for all this is 506, and you can see mean, standard deviation, minimum maximum values, and the percentiles. This is what it tells me. Okay, some statistics involved here. Next, let's go to finding the correlation. Okay, now we go to correlation of the data. Correlation between variables or features and the target. I will press 2 here for the heading. So what I do is I will plot it dot figure, and how do I write this? How would I set the size of it? I will set it as fixed size and equals, this could be like 12,6, and from SNS I will take this heat map and df.corr correlation. It will tell me of df, and I will also set the annote as true. This annote will give me the values within the blocks. So this plotting, okay, we got our heat map. So you can see here that this is a matrix which we got for correlation, and the values is inside. So with the target, the crime has negative correlation, but it is also highly correlated. The positive correlation is of Zn, Chas, Rm, rooms per dwelling, distance, DIS, okay, and B, black population. And the negative correlation are the tax, L stat, we can see, RAD, this is the radial distance from the highways, age, NOx, pollution, and index, okay. So you can see the negative and positive correlation. Also you can see the relation among the variables. Suppose the age and the dis, they are highly related, although negatively, but they are related, okay. This is the age of the owners, and this is DIS is your distribution. DIS was if I'm not wrong, this is DIS was distance to 5 Boston employment centers, okay. So you can just always come and check what was the variables. Now let's come to finding out different things now, okay. And let's go on to Unimodal data visualization, and that means we are going to plot histograms. So I will go to histograms and I will plot them for the histograms for the entire thing. So let's check out. So what I do is I write df.hist. So PLT has matplotlib has this utility of histogram. So I set the figure size is as equals 12,12, and let's see. Okay, so if you don't want this, just put a comma. Oh, sorry, put a semicolon, and this would be gone. So we find this histogram, and we see that the shape. This tells me the shape of the distribution, and we see that the owners are, in. We can see the distribution of age, like it is greater than 50 when you can really own a house. And this percentage of black, you can see black population, it's greater. Few are here, and so graph is not bell curved. We see bell curved here, room per dwelling, and it just goes on increasing and then decreases to greater than 8 and 9. Similarly, you can find of different this population, this pollution of nitrous oxide, the tax distribution. So this lab is absent here, and what else? The crime. Okay, and now we have to also, this will also help us to understand that how these variables really affect the target, how crime affects our target, you know if crime rate is high, whether people will buy dwellings, buy houses at that price, and if yes, the prices would be low. And we see the target, that is the pricing, is segregated in this bracket, like greater than 10 and less than 30. Okay, fine, we get a rough idea of it. Now let's move on to plotting the box and whisker plot. Okay, whiskers plot. Now this plot helps me to identify the outliers. So this helps me in identifying the outliers. Outliers are the extreme values, either positive or negative. So again, I will use df.plot, and the kind I want is box, and this is come into brackets. I will want subplots as true, and I want the layout as 4,4. It will be arranged like that, and I want the font size as 8, and let's set the fig size. The figure size would be, it has to be equals to 12,12. Okay, and I'm sorry, I have to just erase this also. So you can see this, the box plot. Okay, so the crime rate has so many outliers, and ZN. Even the black population has so many outliers. Parent-teacher ratio has outliers. RM, room per dwelling, has outliers. This age has a long whisker. So we find that these outliers will affect my model performance, and these have to be removed, or they have to be balanced in a certain way before training my model. I can also show you if you want to just plot single plots. So what you do is SNS dot distribution plot, and I want to do the distribution plot of what? Of the target, let's say. Okay. Target. What I get is this. So you can see here that it is maximum pricing is like from the average, if I can say, is from greater than 10 to line between 30, and maximum goes on to like 50. Okay. Next, if I want to see another feature, if I'll show you, is of joint plot. And here I give an X. I will give, suppose I want to see room per dwelling and how is it related to target, and I give it Y is equals to target, and I will give that from where it will take it. It will take it from data.df, and the kind would be, suppose I want that hexagon, and let's set the color also, and the color will be green. Okay, so it is giving me the joint plot. So you can see the histogram here and the scatter plot here. So it is a combination of scatter and histogram, and I see rooms per dwelling. The maximum, or you can say the average, rooms are between like 4 to 6, and the pricing is also concentrated here, as you can see it here, and the maximum rooms goes to 9, which means the higher the rooms, higher the number of rooms, higher the prices. And mostly people are limiting themselves to 5 to around 7 or 6 rooms. Okay, manageable. So this was joint plot, and you can just go on with more plots if you wish. You go on with experimenting with different targets. You can just go here, C, B, and see how does it look. This means that the percentage of black population, so you can see here, is it affecting any housing prices? And we see that no, it does not affect. And the concentration of black is like same. Okay, here 20, 30, and people are not affected by this. You can change this again, this variable, to tax if you want. I think this is, yeah. So let's see. Tax is not there, fine. So let's take this tax. Okay, we don't have tax here. So crime. Okay, so just we can analyze it by crime also, that higher the crime, lower the prices, and no crime, higher the prices, right? Okay. So this goes with our data analysis, visualization, exploration of Boston dataset, house prices dataset. And to check out for the entire code, please visit the GitHub link for the entire code, training and testing of data. And stay tuned for more interesting projects. Thank you.